This section is on logarithmic and exponential equations, and we've done some of these in the sections on logarithms and exponentials, but we're going to actually do some more equations here. So at the top you'll see steps for solving exponential equations. It says 1, obtain the same base on either side. 2, if you can't do that, then isolate the exponential term and take the log of both sides. Either do that, use a property of logs, and then solve for the variable. So let's look. There's a little reminder at the top. It says, remember, if a to the u equals a to the v, then if the bases are the same, u equals v. So let's look at example 1. It says solve 1a. 2 to the x equals 5. I can't get the bases the same. So we're going to take the log, or the ln, of both sides. So the ln of 2 to the x equals the ln of 5. Now we know that since that's an exponent, I'm going to use my power rule, my property of logs, and bring it down front. X ln of 2 equals ln of 5. And now if I divide both sides by ln of 2, you see that x is equal to ln of 5 over ln of 2. Now that is what we call an exact answer. We can get an approximate answer by putting that in your calculator, and you will get x is approximately equal to 2.322. I am much less interested in the approximate answer than I am in the exact answer. Let's look at B. 8 times 3 to the x. First off, don't even think about doing 8 times 3, okay? Equals 5, by the way. Here, I can't get the bases the same, and so we are going to isolate the exponential term by dividing both sides by 8, and I get 3 to the x equals 5 over 8. Now I'm going to take the ln of both sides and bring that x down to the front. X ln of 3 equals ln of 5/8. Now I can divide both sides by ln of 3, and I get x equal, here's my exact, ln of 5/8, that's one separate term, over ln of 3, and that's the exact answer that I want. I don't really care what the approximation is on that. Let's look at C. We have 5 times 2 to the 3x equals 8. Again, we want to isolate the exponential terms, so we're going to divide both sides by 5. We get 2 to the 3x equals 8/5. I'm going to take the log of both sides, the ln, bring that 3x down front, so I get 3x ln of 2 equals ln of 8/5. And now this is similar to the last one, it just has one extra step. So I'm going to divide both sides by ln of 2, and instead of just having x, I have 3x equals ln of 8/5 over ln of 2. Now if I divide both sides by 3, all I have to do is put that 3 right there. You can do that. And you have x equals ln of 8/5 over 3 ln of 2, but we're not quite finished because 3 ln of 2, I can simplify that a bit. So I've got ln of 8/5 over ln of 2, bring that 3 up cubed, so I have x equals ln of 8/5 over ln of 2 cubed is 8. And we have the exact. Alright, let's do D. We have 3 to the 1 minus 2x equals 4 to the x. Can't get the bases the same, so I'm going to take the ln of both sides. So ln of 3 to the 1 minus 2x equals ln of 4 to the x. Bring your exponents down front. 1 minus 2x ln of 3 equals x ln of 4. Now what I need to do is get the terms that have the x in them together. I'm actually going to distribute the ln of 3 to both of those two pieces. So when I do that, I have ln of 3 times 1 is just ln of 3, minus ln of 3 times 2x is 2x ln of 3. We're going to leave this side alone for a while. Now I'm going to add a 2x ln of 3 to both sides, again because I'm trying to get the terms that have the x in them on the same side. Ln of 3 equals x ln of 4 plus 2x ln of 3. Now, they have an x in common. I'm going to factor that out. Ln of 3 equals x times ln of 4 plus 2 ln of 3. Alright, we can keep going. I want the x by itself, but before I do that, let's go x times ln of 4 plus ln of 3, bring the 2 up squared. So ln of 3 equals x times ln of 4 plus ln of 9, 3 squared. Now I'm ready to divide by both sides by ln of 4 plus ln of 9. Ln of 4 plus ln of 9, and yes, this is a pretty rigorous problem, and we get x equals ln of 3 over ln of 4 plus ln of 9. That was a doozy. All right, let's look on the back. Steps for solving logarithmic functions. It says use algebra log properties to isolate the log terms. Logarithmic functions are one-to-one, therefore the log, let's remember this, the log base a of m equals the log base a of n means that m equals n. And you have to check your solutions on these. So let's look at example 2 here, which is logarithmic equations. It says solve 2 log base 5 of x equals log base 5 of 9. First thing we're going to do, this is kind of just the opposite of the steps we took in the last ones, is we're going to bring that 2 back up. So we have log base 5 of x squared, that becomes an exponent, equals log base 5 of 9. So I know now, because I'm taking the log, same base, that x squared equals 9. So x must equal plus or minus 3, but remember, x can't be negative 3 because the domain, I'm going to put because the domain is that x is greater, than 0. So I have to discard the negative 3. So I have x equals 3. So what we would have, if you check it, is you would have 2 log base 5, take out the x, put in the 3, equals log base 5 of 9. Bring that 2 up, log base 5 of 3 squared equals log base 5 of 9, or log base 5 of 9 equals log base 5 of 9, and it checks. All right, let's look at example 3. Here I have log base 5 of x plus 6 plus log base 5 of x plus 2 equals 1. So I'm going to apply one of my rules here. I've got the addition of 2 logs with the same base, so I know that means a multiplication product rule, log base 5 of x plus 6 times x plus 2 equals 1. Now I can write that exponentially. I can say the base 5 to the first power equals x plus 6 times x plus 2. Let's FOIL that out, and we get 5 equals x squared plus 6x plus 2x plus 8x plus 12. FOIL that out and you'll see. And now I just have a quadratic equation. I get 0 equals x squared plus 8x plus 7, so I'm going to try to factor it. I want factors of positive 7 that add up to positive 8. That's 7 and 1. So 0 equals x plus 7 times x plus 1. So using the zero factor property, either x plus 7 equals 0 or x plus 1 equals 0. That would give us x equals negative 7 or x equals negative 1. But let's look at domain. We know that the domain must be greater than 0. The domain of what we're taking the log of. So x plus 6 must be greater than 0. And we know that x plus 2 must be greater than 0. Well, this gives me x must be greater than negative 6. And this gives me x must be greater than negative 2. Well, let's look at the answers we got. Is negative 7 greater than negative 6? No. Is negative 1 greater than negative 6? Yes. Is it greater than negative 2? Yes. So I end up with just one solution. And you can plug it in and check it on your calculator, and it will work. All right, let's look at example 4. And as you can see, these are a little harder than the exponential equations. It says solve ln of x plus ln of x minus 4 equals ln of x plus 6. So using our rules, our product rule, ln of this times this, x times x minus 4 equals ln of x plus 6. And they're the same base, so I can say then that x times x minus 4 equals x plus 6, or x squared minus 4x equals x plus 6. We're going to get everything on the same side, and we end up with x squared minus 5x minus 6 equals 0. So we're looking for factors of negative 6 that combine to make negative 5. Think it's got to be negative 6, so it's negative 6 and positive 1, not 3 and 2. So you've got x minus 6 times x, hang on, ran out of ink. So x minus 6 times x plus 1 equals 0. So using the zero factor property, I set the 2 equal to 0, and we get x equals 6 or x equals negative 1. But again, let's go back and let's review the domain. I know that this, and this must be greater than 0. So x must be greater than 0, x minus 4 must be greater than 0, and x plus 6 must be greater than 0. So this just gives me x must be greater than 0, this gives me x must be greater than 4, and this gives me x must be greater than negative 6, sorry. So when you put that together, here's my negative 6, here's my 0, here's my 4. So the one that x must be greater than 4. Okay? So this one isn't going to work, is it? But x equals 6 does. You need to practice these quite a bit. There's several of these on your final exam.